Alright, Assalamualaikum everyone. Welcome to lesson number 3 on AS Organic Chemistry. I'm your instructor Mariam Shaukat, and today we will be talking about functional groups. So we have already seen the definition of functional groups in our previous video, which was basically that functional group is an atom or a group of atoms within a molecule that determines the characteristic chemical properties of that molecule. In other words, if you can आइडेंटिफाई कि कौन से फंक्शनल ग्रुप्स मौजूद हैं किसी भी ऑर्गेनिक मॉलिक्यूल के अंदर, तो आप उसे अंदाज़ा लगा सकते हैं कि इट विच ऑर्गेनिक और विच केमिकल रिएक्शंस will that molecule go through, which reagents will it react with, etc, etc. So basically you can judge its chemical properties and reactivity, keeping the functional group in mind. And that is why we also say most of the time that the functional group of any organic molecule is the most reactive part of that organic molecule, because this is the part which is involved in the chemical reactions. All right, now we will look at different homologous series, and I will basically, you can say, draw out their different functional groups which are present in these molecules, and we will also learn to name these functional groups. Some of these you might have seen in your O levels or at one point or another. Some of these may be completely new, and therefore I'll go particularly slowly while mentioning them, so that the newbies can follow us along as well. So, as far as the alkanes are concerned, alkanes have basically CC single bonds, all right, and we don't particularly name this as a functional group. So, if you have an alkane in front of you, if you have a organic molecule which has all CC single bonds, we don't particularly consider that to be any functional group. So, you don't need to worry about alkanes being a functional group or mentioning this at all. However, as far as the alkenes are concerned, they have a CC double bond, and we do consider this as a functional group. So, if you see a molecule where you see a CC double bond, then you will mention the functional group as alkene. You will name it as alkene. If you have to draw it, this is something that you will draw out if you want to draw the functional group, and this is the name of that functional group, which is simply alkene. All right, as far as alkynes are concerned, they have a CC triple bond, and these are termed to be similarly as alkyne groups. Now, let me mention one thing, that alkynes are not part of your A level syllabus, so you don't particularly need to worry about them, but you should at least be able to identify that if a molecule has CC triple bonds, then it has a alkyne group present in it. All right, then let's move on to alcohols. So, alcohols basically have this OH group, and the very famous name of this OH group is the hydroxyl group. It's famously called that. Um, Now, in whichever molecule you see this hydroxyl group present, you will name its functional group as alcohol. Now, as we will go along the course, you'll realize that we have primary, secondary, and tertiary alcohols. And so, whenever we are mentioning the functional group, we also mention if that alcohol is primary, secondary, or tertiary. For the people who are hearing this for the first time, you do not really need to worry about this, because it will be covered at one point or another. But for now, just remember that when naming the functional group, we simply say alcohol. Okay, then we move on to our haloalkanes. So, in our haloalkanes, we basically have some halide which is attached to our organic molecule. So, this X basically can be bromine, it can be chlorine, it can be iodine, right? It can even be fluorine. So, basically, this X can be any halogen: bromine, chlorine, iodine, or fluorine. So, if in any organic molecule you see bromine, chlorine, iodine, or fluorine attached, then that basically belongs to, you can say, the haloalkanes. This functional group is called as the haloalkane. So this is what you will basically be looking for. Now I will do a sample question at the end, and you can see over there how we can identify the different functional groups in a given molecule. But for now, I hope that at least you can make sense of what we are looking for in each case. All right, for carboxylic acids, you need to find this group. This is famously called as the carboxylic group. All right. So this is something that you're looking for. Um, Let me write that in red. Um, so we call this as the carboxylic group. And then again, the name of this functional group, whenever you are asked to name the functional groups, you'll just simply say it has a carboxylic acid in it as well. And you're looking for this COOH. Let me also write down the expanded form. It looks something like this: COO and then OH, and this is attached to an organic molecule. Whatever is on this side of the dash is basically the organic molecule, that which is usually a carbon atom. All right, I hope things are making sense up till this point, because we have not introduced any new organic or homologous series which you are not aware of. And then we have esters. So this is also something that you have already seen in your O levels. The group looks something like this, all right, and you have a carbon and carbon groups attached on either side of this um, dashes. And this thing right here, then again, if you're ever asked to name the functional group, it is simply an ester group. So I hope this is making sense as well. Then we move along. We have something called as aldehydes. Now this is something which will be new for people who are doing or watching this video as completely newbies for A level organic. Aldehydes are basically another functional group, just like carboxylic acids and esters. However, the slight difference is that these have a C double O bond, but on one side they have a hydrogen attached. Now look very closely. Carboxylic acids have a C double O bond, but they have an OH attached on this side, and this side is free to be attached to the remaining part of the organic molecule. For esters, they have a C double O bond, and oxygen is attached, but alongside this oxygen, you have then some carbon group here and some carbon group here. For aldehydes, it has a C double O bond and a hydrogen is directly attached to this carbonyl carbon. This group right here, C double O, is called carbonyl. So you directly have this H attached, and on this side you can have any carbon group. If you're asked to mention the functional group, you can just simply name it as aldehyde. Aldehyde group. And then for ketones, now this is slightly different. Now, in the case of ketones, you can see esters and ketones look very alike, but they're not exactly the same thing. Why? Because in esters, you have a C double O bond, and then you have an oxygen attached to this carbon, and in turn, with this oxygen, you have some R group. R group is basically some alkyl chain here, some alkyl chain here. But for the case of ketones, this is a C double O bond, and then on this side and on this side, you have a alkyl group. So there's no oxygen in the middle, right? So look very closely to carboxylic acid, esters, and aldehydes, and make sure that you get the distinction. You do not want to confuse yourself with this notation. We usually write aldehydes as CHO, and we write our ketones as CO. It's not particularly CO, but I've not introduced the concept of alkyl groups yet, so therefore I will not be mentioning anything other than this. Alright, so if you're asked to mention the group, it is simply a ketone group. Okay, then we move on to amines. So amines are perhaps something new to you as well. Amines are basically, you can say, they have this group NH2 attached. So any organic molecule which has NH2 attached with it is called as an amine. All right, and then again, if you're asked to mention the group, you can simply say it's an amine group. Sometimes it's also called as the amino group, but we usually prefer to use this term, amine. Okay. And then you have your nitriles, and nitriles have a CN basically bond in them. And if I were to draw these in an expanded form, this is basically H like this, and this right here is C triple bond N. This is basically the expanded form, and if you're asked to mention which functional group is attached, we simply call this as the nitrile group, right? So nitrile group is that C triple bond N, this thing right over here. Okay, Then we move on and talk about arenes. Now, if you have watched the lecture number 0, you would have seen that there are some aromatic hydrocarbons, which we will talk about in A2 organic in detail, but we will touch upon them in AS. And we said that, these are basically our benzene and its derivatives. So benzene was basically C6H6, all right? Now, if in this C6H6, I remove one of these hydrogens so that I can replace it with some other group, then this group right here, which is basically C6H5, this thing right here is called as the phenyl group, and this thing right here is basically your another functional group. We usually call it as benzene. Whatever is attached, if we are asked to mention well which group is involved, we usually call this as a benzene group, or if you want you can write as the phenyl group. It looks something like this. So same as benzene, but something is attached onto it, and this can be basically anything at all. So these are basically called as our arenes. Now things will get clear one by one as we will do more and more practice questions. So do not worry. All I want you to know at this point is to remember which groups correspond to which functional group, or basically which combination of atoms corresponds to which homologous series. That's it. Alright, as for amides, amides are slightly different than amines because in this you have a C double O bond, but next to it you have an NH2. So this is NH2 in itself, and in amides it is C double O and NH2 next to it. Alright, and if this is something that you would have seen in biology as well. This is basically your CONH, and then there could be something on this side as well. Basically what I did over here was remove one hydrogen and then replace it with anything. This in itself is still an amide. In an amide, all that we're looking for is the CON bond. So there should be a C double O bond, all right, like this, and there must be a nitrogen which is directly attached to this carbon. Then again, the depths of amides is not something that we are concerned with. All we want to learn is how to identify which molecules have an amide functional group involved. Again, if you're asked to mention the group, it is going to be named as an amide group. Lastly, we come to our acyl chlorides. Acyl chlorides are also COO, but next to them you have a chlorine attached. Now, let me be very particular. This is chlorine. This is not any other halogen. This is chlorine. That's why we call it as a acyl chloride. So don't mix this up. This is a chlorine. It will remain a chlorine. And yeah, if you're asked to mention, or label the functional group, just say that there's a acyl chloride group involved. Now I know that you will encounter and you might be encountering a lot of these homologous series of functional groups with a lot of C double O bonds, and so it is very important for you to make yourself familiar and comfortable with identifying each one of these. Now in one of our upcoming videos, which will not be the theoretical lessons, there will be practice questions will be solved in our basically practice videos. These will not constitute our lessons. They will basically not be numbered as lessons. They will be simply just be posted, and they will talk about the different topics that we have already covered in the form of basically past paper practice. So I hope you enjoyed this video. If you did, then give it a big thumbs up, subscribe to the channel, and hit the bell icon. I will see you next time. Till then, Khuda Hafiz.